Hello everyone, myself Lakshana Bachcha. My topic for presentation is real-time scan conversion and run length encoding. Let's begin. Scan line conversion definition. It is the process of representing the graphics object, a collection of pixels. The graphics objects are continuous. The pixels are used are discrete. The video display device of the computer is capable of converting binary values 0 and 1 into a pixel on and pixel off information. 0 is represented by pixel off and 1 is represented using the pixel on. Using this ability, graphics computer represent the picture having the discrete dot. Examples of objects which can be scan converted: point, line, sector, arc, ellipse, rectangle, polygon. The process of converting is also called as the rasterization. Algorithm implemented the various from one computer system to another computer system. Some algorithms are implemented using the software. Some are performed using hardware. Some are performed using the various combinations of hardware, firmware, and software. Pixel. Term pixel is short form of the picture element. It is also called as point or dot. It is the smallest picture unit accepted by display device. Each box is represented as a pixel. 5,5 is the address of the pixel. Picture is constructed from 100 of such pixels. Pixels are generated using the commands. Lines, circles, arcs, characters, curves are drawn with the closely spaced pixels. To display the digital or letter matrix of the pixels are used. Pixels are also defined as the smallest addressable unit or element of the screen. Each pixel can be assigned an address as shown in the above figure. Different graphics objects can be generated by setting the different intensity of pixels and different colors of pixels. Each pixel has some coordinate value. The coordinate is represented using row and column. In above example, we seen P5,5 used to represent a pixel in a fifth row and the fifth column. Each pixel has some intensity value which is represented in the memory of computer called as the frame buffer. Let's see the scan converting a point. Each pixel on graphics display does not represent a mathematical point. Instead, it means a region which theoretically can contain an infinite number of points. Scan converting a point involves eliminating the pixel that contains the point. For example, display the coordinates points point 1, point 2. These are the columns and these are the rows. The display device coordinate 5, 2. This point is displayed on the pixel coordinate 5, 2. As shown in the figure, would both be represented by pixel 2, 1. In general, a point px, y is represented by the integer part of x and the integer part of y, that is the pixels int x and int y. Scan converting a straight line. A straight line may be defined by two endpoints and equation. In the figure, two endpoints are described, x1, y1 and x2, y2. The equation of line is used to determine xy coordinates of all the points that lies between these two endpoints. Using the equation of straight line, y equal to mx plus b, where m is dy upon dx and b is the y interrupt, we can find the values of y by incrementing x from x1 to x2. By scan converting these calculated xy values, we represent a line as a sequence of pixels. Algorithm for drawing line using the equation. Step 1. Start the algorithm. Step 2. Declare the variables x1, x2, y1, y2, dx, dy, m and b. Step 3. Enter the values of x1, y1, x2, y2. x1, y1 are the coordinates of starting point of the line. x2, y2 are the coordinates of ending point of the line. Then step 4, we have to calculate dx, which is x2 minus x1, and calculate dy, which is y2 minus y1. Calculate the slope of the line m equal to dx upon dy. Then calculate b equal to y1 minus m into x1. It is the decision parameter. Step number 8. Set the x, y coordinates equal to the starting point, that is lowest point, and x end equals to the largest value of x. If dx is less than 0, then x equal to x2, y equal to y2, and x end is equal to x1. If dx is greater than 0, then x is equal to x1, y is equal to y1, x end is also equal to x1. Step 9. Check whether the complete line has been drawn. If x equal to x end, then stop. Plot the point at the current xy coordinates. Increment the value of x, that is x equal to x1. Compute the next value of y from the equation y equal to mx plus b. Go to the step 9 till we got the endpoints of coordinates of line. What is run length encoding? Run length encoding is the basic type of data compression in which an input stream of data, such as this is the example is given, is provided, and the output is the series of counts of successive data value in the row, that is 3p3r7s is the output of the given input. Since there is no loss in this type of the data compression, the original data can be fully retrieved upon the decompression. The algorithm's flexibility in both the encoding and decoding process is one of its most appealing qualities. This type of the data compression is lossless, meaning that all the original data is recovered when decoded. One of the algorithm's most attractive aspects is its easiness in both encoding and decoding. Let's see the example of run length encoding. Here is the example of data stream in its original and encoded form. In this example, we have given data input as a 29 characters. The characters are then compressed into the 12 characters, which is the function of run length encoding. In conclusion, the real scan conversion and run length encoding are the two essential techniques in the computer graphics and image processing. In the real-time scan conversion, efficiently transforms geometric primitives into the pixel representations, crucial for rendering graphics on screens. It ensures smooth and accurate rendering, particularly in interactive applications like video games and simulations. On the other hand, run length encoding optimizes storage and transmission of images by compressing consecutive pixels of the same value into the shortened representations. Thank you for listening the presentation.